Hi, in this video we are going to learn a very profound feature of GeoGebra, that is translate of any function along a vector. And we will also see how this can be done with the help of a slider as well. So for that, let's jump into GeoGebra. Alright, so we are in GeoGebra now, and here suppose I have a function, let's call a function y is equal to x squared, and I want to translate it along any given vector, and let's call the vector we have is 3, 4. It means the x component of that vector is 3 and the y component of that vector is 4. So to actually write a vector, we have to just type vector, the vector, and there is a bracket now, and in bracket we have to simply put 2 points, the initial or the starting point and the final point. So actually we want to draw a vector that is the x component of that is 3 and the y component is 4. So the starting point of the vector should be origin, so we'll call the starting point as 0, 0 and comma, and the final position or the final point will be 3, 4. So this is the vector we have drawn, and now I want to translate this function along this vector. So there is another way to do it mathematically, because you notice that if we want to draw a function translated along this vector, what I get? I simply get a new function which has the vertex at 3, 4. It means at the tip of this vector, and this effect can be shown in a single step. How do we show it? Let's type translate, and if you sorry, this is actually translate, so translate, translate, and as soon as you type translate, there is a menu here, drop down menu, in which it is asking translate object and vector. So we just select that because we have the object f, and that object should be translated along this vector u. So we call the first parameter or the first argument of this function is f, and this vector is u. And now you see there is a graph, or there is a curve drawn at the tip of this vector, and this curve y is equal to x squared is now translated along this vector at the maximum. But can we do it better? Because in this scenario we can't see the transition happening. We want to actually try to feel the effect of the process. It means I want to see the complete transformation happening at every single moment. In short, we want to see the animation. So how do we actually animate it? So for that, let me just disable this function, and now we want to use a slider to do that. So we call a slider s and then enter, and we have a slider, but this slider has the minimum value -5 and the maximum value 5. I want to change it, so I will go to settings, and in slider I have to change the minimum as 0 and the maximum, let's let it be 5, and just hit the enter. So we have this slider s, and now I want to draw a vector which is along this vector u, but it is dependent on s. It means when I change the value of the slider, that vector should change its length according to the slider value or the s value. So how do we do that? We call a point. So let's call it, the point is a, and that point should be on or along this vector u. So how do we do it? So a is equal to, and we simply make that point dependent on s, so we'll just take the proportion of 3 and 4 but dependent on s. How do we do that? Is 3s comma 4s, and now we get there is a point dependent on the value of s, but you can notice this is exactly along this vector u. How do we see that? If you change the value of s, you see this point is along this vector u. And now this point will enable us to actually create a variable vector. So how do we do that thing? So we simply call the vector v. Let's call this vector v is equal to, and I want to actually type a vector which has a starting point 0, 0. Let's call 0, 0 is the starting point, but the final point should be a. And now you see there's a vector here. So this will enable us to actually make this vector variable, at least its magnitude variable. How? It dependent on s now. You see that as soon as I decrease the value of s, the size of the vector will decrease, and when I increase the value of s, the size of the vector will increase. So what I do now, I will just disable this vector u already drawn and now have a new vector v, which is actually going to help us to translate this curve along this vector dependent on the slide in a animated way. So for that, let's just disable this vector v because I don't want to see this vector disturbing us. So we disable it, and also this point a. So we have this curve only on this plane, and now I will do the same translate command, and for that the object will be f again, but the vector will be now v. So we just call translate, and here I have the object f, but the vector is now v, and just hit the enter. Oh, I just typed the spelling of translate incorrectly, so that'll be translate. And now you see, according to the value of s, the vector, or sorry, the curve is already drawn here, and when I just change the position of s or the value of s, you see this translation or the transition is happening, and you can actually show it or see it as an animation. And if you run this animation, you can see that it will always go till this s is hitting this value 5, and again it will come down to get its initial position when s becomes 0, and again there's a loop here, and it will actually oscillate between these two positions according to the value of s. Alright, so that's it for today. I hope you enjoyed this video and learned how do we actually translate any curve along any vector. See you in the next video with some other GeoGebra feature. Stay math active. Thanks.